So lesson 12.5, surface area of prisms. It is really the surface area of the outside surface. And to kind of make you think about this, a rectangular prism, well, think of a Kleenex box. A Kleenex box is a rectangular prism. If you were the person in charge of ordering the material to make Kleenex boxes, you would need to know the surface area of every Kleenex box to know how much material to order. So think of it as knowing how much cardboard to order for a Kleenex box. That's what the surface area of a prism is. Some of the definitions that we have already talked about that's going to be really important would be this right here, the lateral sides. The lateral sides are the sides around the shape, okay? The top and bottom on a rectangular prism, we're going to call those the bases. So I had talked about a rectangular prism. We sit in a rectangular prism in class, and generally you think of the ceiling and the floor as the bases. But it could be any other opposite sets of bases, but for rectangular prisms you usually try to think of the top and bottom, what it's sitting on. Now some of these numbers I can barely read. It is 8 centimeters high. It is 15 centimeters long and 6 centimeters wide. So we're going to talk about how to find the surface area of a prism. The same general formula it holds true. A lot of times on formula sheets you might see this. Surface area is 2 times the length times the width plus 2 times the height times the width plus 2 times the length times the width. And this would be considered the length, this would be considered the width, and this would be considered the height. And you could use that formula, but when I do this, usually what I like to try to do is do what you're going to do for any prism, and this makes sense to me. So first of all, you find the surface area for the lateral sides, and to get the lateral area, L, the capital L stands for lateral, it's P times H. P is the perimeter of the base, and H is the height of the prism. So that would get you all of this around the outsides of the prism. Okay, so we're going to do that first. Oops, that was not the right tool. So L, perimeter of the base. Can somebody tell me the dimensions of our base? What is the dimensions of our base? Morgan? The dimensions of the base. What's the length and width of the prism? 15 and
8.
Not 8. 8 is high. 6. So it's 15 by 6. So we're talking a perimeter of a rectangle that's 15 by 6. So let's just look at that base ones. Here it is. We're looking at it like this. It's 15 and 6. So if I do that, how do you find the perimeter of a rectangle with a 15 length and a 6 width? How do you find the perimeter? Lindsay? I can multiply what? I don't want to multiply 15 times 6 because that'll give me the whole area. We want the perimeter, the distance around it. You could add them all. Yeah, I only see 2 numbers, but how do I know what the other ones are, Freddie?
Those are all equal sides.
They're equal, opposite sides are equal. So there's a 15 up here and there's a 6 over here. Okay? So for perimeter of the base, I could really do this, couldn't I? Couldn't I go 2 times 15 plus 2 times 6? That's the perimeter of the base. And then it says H, height of the prism. So what's the height of that prism? We already said. Bo, what was it? You said it.
15.
Nope, the height.
6.
Not 6. 15 and 6 are the length and width, 8, yes. So the height of the prism is 8. It's how tall it is between the bases. So as I'm figuring up the perimeter of the base, I'm going to follow order of operations, and I'm going to go 2 times 15 is 30, plus 2 times 6 is 12. What's the next step with order of operations? What's my next step in order of operations? What do I have to do? Anybody know? Lindsay? Parentheses. So 30 plus 12 is 42. And I got to take 42 times 8. So if I take 42 times 8 off to the side, 336 is the lateral area. So I take the perimeter of that base, the bottom, 2 times 15 plus 2 times 6. That gets me the perimeter all the way around. We're trying to find the perimeter all the way around. There's 2 15s and 2 6, so that's what we've done right here. The perimeter of the base is 42. The height is 8. So we've got lateral area is 336. Now, here's the best part. If you go ahead and figure this out over here, then let's look at the surface area formula. The surface area is the entire lateral area, so that's where the L comes in, plus the 2 bases, 2 big B's. What did we already say the shapes of these bases are? What shape is it? Rectangles. How do you find the area of a rectangle? How do you find the area of a rectangle? What's the formula? L times W. So let's see if we can get this figured out. So doing surface area for the L, I get to plug in 336. That part's already done for me. Plus 2 times the area of my bases. The base, it's this rectangle we've got over here. I got to take length times width. So that means that it's going to be 15 times 6. So the base, the length and width, 15 and 6. We plug that in. Now I'm going to do 336 plus 2 times 15 times 6 is 90. What's the next step in order of operations? Parentheses, which really means what in this case? Times. Yep. So 336 plus 180. And finally, our surface area, 516. And how should I label this? Let's go back here and look what they were. Centimeters. Centimeters squared, because we are back to area. The entire surface area, 516 centimeters squared. So let's go think what we've done. You find the lateral area first. You take the perimeter of the base times how tall the prism is. That gets you the entire lateral area, so that those sides around gets that lateral area. For surface area, you take the lateral area and add 2 base areas, the top and the bottom. And that's where you look and see, well, what's my shape? This time it was a rectangle, so you use the formula length times width. Okay, are there any questions about rectangular prisms and surface area? Because we're going to switch now to a triangular prism, and we're going to follow the same idea. Okay, anybody else writing in red or blue? Okay, so there is my triangular prism. Now we're going to do the surface area of a triangular prism. So if we've got a triangular prism, that means that our bases are the triangular ends. The lateral faces are the rectangles. So we're going to do the same idea as we did last time. We're going to look at the lateral area first. The lateral area is big P, which is the perimeter of the base, times the height of the prism. So let's look at my base. I'm going to draw it over here. Here's my base. It's that triangle. This distance is 12. Down along the bottom is 20. What's this one over here? Can anybody tell me? 16, because it has to match this side over here. So up on the top right of the triangle, that's 16. How do you find the perimeter of a triangle? How do you find the perimeter of a triangle? Nicole Thielman? Yeah. So what I'm going to do in my formula, I'm going to put a parentheses, and we're just going to add up all the sides. We're going to say 12 plus 20 plus 16. That's the perimeter of my base. Now, what is the height of the prism? How far apart are the two triangular bases? Morgan? It is 3. Yep, that's the height. It's laying on its side, so that's really weird to think of it as the height, but that's the distance between the two triangles. And it looks a lot bigger than 3 anyway, but I don't think I could draw it that small. Okay, so order of operations says you do what's in the parentheses first. So 12 plus 20 plus 16 makes that 48. Everybody good with where I got 48? That's the perimeter of the base times 3. So 48 times 3, 144. So all of those rectangles around the outsides, the total surface area of all those rectangles is 144. Now to find the total surface area, I take the 144, and luckily I just get to plug that part in right off the bat. Plus I've got to go 2 times the area of this triangle here over on the left. What's the formula for area of a triangle? What's the formula for area of a triangle? Half times base times height. Now, what kind of triangle is that one? A right triangle. And the base and the height are the two sides that come together to make the right angle. So what we have in our parentheses is 1/2 times 12 times 16. 1/2 base times height. So I'm going to do this. My 144 just comes along, and 2 times 1/2 times 12 times 16. Well, 1/2 times 12 is 6 times 16. So I'm going to go again. Now 6 times 16 is 96. So I'm going to keep going. 2 times 96, 192. And finally, I add those two numbers together. 336. And how should I label this? Meters squared. So you find the lateral area first. That means the perimeter of the base, the perimeter of this, times the height, the distance between the two bases. Take that number and plug it in. You need the lateral area plus 2 base areas.